Hello and welcome. Let's take a look at what an inverse matrix is. An inverse matrix is a matrix that undoes another matrix. And to explain this, I might actually go back to just normal real numbers here. Let's say I've got the number 7. What do I have to multiply the number 7 by in order to get 1? So 1's kind of like what you get after you scale a number back down to like a standard value. Okay, so 7 by multiplication, undoing it brings it back to 1. What number would we need for this to happen? And the answer is 1 over 7. Okay, we say that 1 over 7 is the multiplicative inverse of 7. Okay, multiplying 7 by 1 over 7 undoes the 7 and brings it to 1. And in the real numbers, you could also call this the reciprocal of 7. Okay, any number times its reciprocal equals 1. In the matrix world, it's both similar and different to that. So let's say we have a matrix here, and we're going to multiply it by an inverse matrix to get it back to like a scale value of 1. Okay, but what's like the standard value for matrices? Okay, it is going to be the identity matrix, which of course is our 1, 0, 0, 1, if we're looking at a 2 by 2 case. So for notation purposes, we would usually call an original matrix something like A, some capitalized letter of the alphabet. The inverse matrix is A minus 1. It's not A to the power of minus 1, it's just a symbol. Okay, we can't do 1 divided by a matrix. It just doesn't work. It's not defined. This is just a symbol, A minus 1. And over here, of course, we have our inverse matrix. So any matrix times its inverse will give the identity matrix. Okay, and that is the definition of an inverse matrix. So what is the inverse matrix here? The numbers are 1, 2, 3, 7. How did I get that? Well, we're going to talk about that in another video. Okay, in this video, we're just explaining the concept of an inverse matrix. So does that work? Do you trust me? I don't trust anything this guy says. Well, let's check if it works using matrix multiplication. Okay, so here we go. To get this entry here, let's do the top row and the first column here. 7 times 1 is 7. Minus 2 times 3 is minus 6. So 7 plus negative 6 is 1. That one's right. Let's check this one. Top row, back column. 7 times 2 is 14 plus negative 2 times 7 is negative 14. 14 minus 14 is 0. That works. Let's check this one. This row and this column. Negative 3 times 1, negative 3. 1 times 3 is 3. Negative 3 plus 3 is 0. That's also correct. Let's check the last one here. Okay, this row and the back column. Negative 3 times 2 is negative 6. 1 times 7 is 7. Negative 6 plus 7 is 1. Okay, so that works. And that is the concept of an inverse matrix. Any matrix times its inverse will always give the identity matrix. Like so. What about the reverse order? Does an inverse matrix times the original matrix equal I? Here's a little task for you to do. Is that also true? Go on, give it a try. So that is the concept of an inverse matrix. Did the inverse matrix times the original also give the identity matrix? Leave a comment. Thanks for watching, and we'll see you again soon.